Have you ever really stopped to think about the magic that happens when you click on something and poof, it just appears on your screen? Well, it's not magic, it's a computer network. So let's dive into this incredible, invisible journey our data takes every single second.
To really get our heads around this, just think about this very explainer. How did it travel from some server, somewhere on the planet, through this impossibly complex web of connections and land perfectly on the device you're using right now? That's the exact journey we're going to map out.
You know, at its heart, it all starts with a network. Let's just forget all the technical jargon for a second. A network, at its simplest, is just a group of devices, your computer, your phone, maybe a smart TV, that are connected so they can talk to each other and share stuff. It's really that fundamental.
Okay, but not all networks are built the same. Think of a LAN, a local area network, as being like the streets in your own neighborhood. It connects all the devices right there in your home or office. But a WAN, a wide area network, that's like the massive highway system. It's what connects all those different neighborhoods, or LANs, together, across cities, countries, even continents. And the internet? Well, that's the ultimate WAN.
So, how does your device actually get onto these digital streets? Well, you need a doorway, right? Every single device has a piece of hardware inside it called a network interface card, or NIC for short. You can think of it as the on-ramp for our data's journey. It's the physical part that lets your computer actually plug in or connect wirelessly to get things started.
All right, so you're on the local network. How does data know which house or which device to go to? That's the job of a switch. A switch is basically the traffic cop for your local neighborhood network. It knows exactly which device is plugged into which port. So if your computer wants to send something to your printer, the switch creates a direct line just for them. It makes sure the data goes straight to the printer without bothering anyone else. It's all about that quick, efficient, local delivery.
And these local networks, they can be laid out in different ways. We call these layouts topologies. A really common one is the star layout. Everything connects to that central switch we just talked about. It's simple, and if one device's cable goes bad, everyone else is still fine. Then you have something like a mesh network. This is more complex, where devices are interconnected with each other, creating all these different paths for data to take. It's super robust, because if one path is blocked, the data just finds another way to get there.
Okay, so we're zipping around our local neighborhood just fine. But what if our data needs to leave town and get on that big national highway? For that, we need a router. The router is the gateway. It's the big exit from your private network onto the public internet. Its whole job is to connect different networks, taking data from your LAN and smartly sending it out into the world, and, just as important, directing the incoming traffic to the right spot in your home.
And this brings us to a really crucial point. The internet isn't some single giant thing. It's exactly what it says here, a global network of networks. It's just countless smaller, private LANs, all stitched together by those routers that act as the bridges between them all.
So with billions of devices all trying to talk at once, how does this not just turn into absolute chaos? Well, it works because every single device agrees to follow the same set of rules, or what we call protocols. The official rulebook for the internet is called TCP/IP. It dictates everything: how data should be broken into little pieces, how to address them, how to send them, and how to put them back together perfectly on the other side. It's the rules of the road.
Now, a huge part of those rules is addressing. Just like a letter needs a specific street address to get delivered, every single device on the internet needs a unique IP address. This string of numbers is the specific, one-of-a-kind destination that tells all the routers out there exactly where to send the information. No address, no delivery. Simple as that.
But let's be real, you don't want to have to remember a long string of numbers like 172.217.14.228 just to check your email. We remember names, like google.com. That's where the domain name system, or DNS, becomes our best friend. DNS is literally the internet's phone book. You type in a name you can remember, and DNS instantly looks it up and translates it into the number-based IP address that computers understand.
So let's put it all together and retrace the journey. First, your browser used DNS to find the IP address for the server where this explainer lives. Then, all the data for it was chopped up into tiny pieces called packets. Those packets were then shot out onto the internet where routers and switches guided them, hopping from network to network, all addressed to your unique IP address. And finally, your device caught all those packets and put them back together in the right order so you could watch this. It's pretty amazing when you think about it, right? Okay, we've mapped out the journey, but there's a huge question hanging in the air. With our personal information just zipping across this giant public network,
how on earth do we make sure it stays safe? How do we stop people from snooping on it?
Well, this is where network security is absolutely crucial. Two of the biggest tools in the toolbox are firewalls and encryption. A firewall is like a digital security guard standing at the gateway of your network. It inspects all the data coming in and going out, and it blocks anything that looks suspicious. And encryption, that's like taking your data and writing it in a secret code. It scrambles the information so that even if somebody manages to intercept it, it's just a bunch of gibberish to them, unless they have the secret key to unlock it.
And here's something else to remember. For so many of us, that first step and that last step of the journey is completely invisible. There's no cable. Wireless networks, like the Wi-Fi in your house, use radio signals to do the exact same job, connecting our devices to the network and sending all those data packets flying through the air to the router.
And finally, let's think back to where this whole data journey probably started. I said it came from a server somewhere. Well, more and more, that somewhere is what we call the cloud. Cloud computing just means that the actual servers, the storage, the software we use, it's all located in these massive, super powerful data centers all over the world, and they deliver services, like this very explainer, to you over the network we've just been talking about.
So from a tiny LAN in your home all the way up to the global internet, from routers and switches to firewalls in the cloud, we've traced that incredible invisible journey of data. But it kind of leaves us with one last big thought. As our world gets more and more connected, as we plug everything from our cars to our coffee makers into this network, what do you think is the next great challenge we're going to face for making it all faster, safer, and more reliable?